Hello, everyone. Today we're going to be going over how to do the four-bar motion study. Um, so the first thing you do is download the zip folders that are provided in the canvas, and the parts for the assembly are already provided for you. So once you download them, we can extract them since it is a zip file. Then we can open up SolidWorks and start a new assembly. And then we can, excuse me, insert our components. For this assembly, we have two of the first link called link one ground. Now you could either add them in one at a time and constrain them as you go, or you can add them in all together, just place them more or less where they should be, and then constrain them, which is what I'll be doing. So we have link two, also add link three, and then finally link four. So for my first constraint, or my mates, these two shouldn't be moving. These two will be our fixed parts. Um, before we are able to constrain them where we want them, we should make sure they're floating, so we're able to move them around. And these two, like I said, are going to be our foundation. So the constraint that I want for this first part, I can make a mate, and then I want to constrain. I want to find that linkage, which is this guy here. I want to constrain its origin to the origin of the assembly file. So now they share the same origin. Make sure you have our axes aligned. So that one's now fixed. My next constraint should be linkage 2 to linkage 1. For the four-bar linkage setup, these faces should be coincident to each other. Could finish that. Then I can also make the bores concentric. So what that does, now that these are the bores are concentric and the faces are mated together, this basically rotates around the same about the same hole. So we'll just keep adding to our assembly here. Let's keep adding more mates, and they're very similar. So the next mate should be the front face of linkage 3 with the back side of linkage 2. Go ahead and add that. Similarly, let's excuse me, also add the concentric mates to the bores. Now when I grab it, you can see what those mates do. So let's keep adding on. For this linkage 4, its backside should be constrained with the front side of linkage 3. Same thing with the concentric mates. And then also this and this should be concentric. Looks like it moved it to the back. So I can flip the alignment, move it to the front where I want it to be. Now this one should also be mated to the ground, such as our first support is, so we can add a constraint from the bottom faces. So now those two are in line with one another. And our final constraint should be a distance mate um, between the first and second support. Uh, so you can click on any face, just any part of them. You want to add a distance mate. In this case, would be 12 inches, just something so they're fixed relative to one another. So now these shouldn't move. So now that we have everything mated, actually it looks like we have a problem here. Let's go ahead and fix that. What I could do is find whatever mate was causing that issue, which I believe to be this one. I'll just delete it. Should be able to move this slightly forward. Let me go ahead and now add a concentric mate once more. So this and this one should be concentric, which they are. Um, and then the final mate should be between these two faces. Looking back at it, I think that concentric mate was fine. I just didn't have the mate between the two faces. So you could have just added that and it would have been okay. So now we have our very basic 4-bar linkage setup. And I should be able to grab this component and rotate it. Should not be able to move the supports. So I'll try to do that and cannot move them. So that's fine. That's what we want. Now that we have our assembly constraint and set up like we would like it to be, let me move this out of the way. All right, hopefully that doesn't bother you guys too much, or maybe I can hide it. There we go. So now that we have our assembly set up, we can go to motion study down at the bottom. Let me expand this a little bit. So in motion study, right now we have two options, animation and basic motion. As you can see, animation is motion driven by key points or motors and constrained by assembly mates, where basic motion is a little bit more realistic of a simulation using assembly mates, springs, gravity, and motors. So for the purposes of this demonstration, animation will be just fine. We just want to show the motion that can happen with the given constraints. Um, and what we want to do to add a motion, we can add a motor, which is what I clicked right here. I clicked on the motor. Um, this is the face that we want to select to be driven, the inner ring of linkage 2, I believe that is. And then it shows you the direction of travel that the motor will be driving. If you're rotating, which is under rotary motor, and if right now it's going clockwise, excuse me, if we wanted to switch it, we could switch it to counterclockwise by clicking on this button. We could also select if we want, let me see if I can move this. It's a bit hard to see. Um, I'm not sure why it's like that, but you can read it. There's a few settings. We have constant speed, distance, oscillating, segments, data points, expression. For this demonstration, constant speed will be just fine. You can set the specific RPM that you want your motor to be rotating at. RPM standing for revolutions per minute. So 60, we'll set it to 60 right now just to slow it down a little bit from 100. Might have been too fast. So now we set that motor to 60. We went ahead and finished it. And if we play the animation, you can see it rotates that second linkage. And due to the constraints, it rotates the entire linkage assembly. And at the end there, I don't know if you heard it, there was a bell that's a little chime that signifies that you reached the end of your motion study. So I think 5 seconds is a bit too long for this demonstration. So if you grab this key here, you can shorten it. There's a timeline bar up at the top. So I can shorten it to 2 seconds. If you ever make any changes, you most of the time want to hit calculate. Which is that calculate button is similar in my opinion to the rebuild button whenever you're working on an assembly and you make some changes. SolidWorks asks you, do you want to rebuild now? Most of the time you hit yes, so you can rebuild, and then your assembly would adopt those changes that you've made to your parts, and then you can go from there. So similar with the calculate button. If you make any changes, you want to hit calculate. If you just hit play, it wouldn't have adopted those changes that you've made. So now when I hit play, same motion, same speed, but this time 2 seconds long versus the 5 that I had previously. You can change the playback speed, so I can speed it up 2 times. If you want to fast forward through it, you could also slow it down to half speed. It'll just slow it down a little bit. Change this back to 1. Um, let's see what else. That's pretty much it for this very basic demonstration. Um, again, you hit play or play from the start, and it'll run through your motion. So that was pretty much it for this first 4-bar linkage setup. Thank you.